So I will teach you how to do this problem, deform problem. So maybe you can pause and you can read what is the instruction and what are the values. So I will start working on it. I will open the deform. So now we make a new problem and next finish. I will make this video just to give you idea how to solve problem in the exam. Maybe values will change, or maybe I don't know, maybe question will change. So if the question will be same, then you can solve. So this is the workpiece, okay, and what we have to generate, top die and bottom die. So top die and bottom die. Now we will give the geometry to these objects. So geometry, geoperimeter, and for the workpiece what we have, yes, so for the we have width of 25 and height of 14, length of 20. This is created. Now we have to create top die. So top die, we have to go here, cylinder, and its die is 100 and its height is 40. Top die geometry is created. Now we make geometry of bottom die. Cylinder, again same diameter 100, height 40, create. So geometry is created. Now what we have to do, we have to assign the temperature. So for the workpiece it was 250, and for bottom die, top die it was 200, bottom die 200. Now we assign the material. For workpiece we will assign, in the question it was aluminum 5454, something like this. So we will, no, in the question it was 5456, so I cannot find 5456 in the database. So you can or whatever you choose, but I choose here 5454. So loaded. Now load the material of top die, and it was some steel, the 1015, yeah. So here we see 1015 load. So now for the bottom die we give the loaded material. So it was 1015. Up to now it's shaped and material is given, template is given. Now we will mesh it. Yeah. So workpiece mesh 32,000, no problem. It will mesh workpiece here. It's taking time because of 32,000 elements in mesh, so that's why. And yeah, my machine is slow. Do you want to assign the default boundary conditions? Yeah, for right now we want default, yes. And again we need to mesh top die. So mesh it. So here it's saying date you should turn on the heat transfer as in question. So, or you want to change the object type. So the top die is rigid. So we have to turn on here heat transfer. It's turned on. Now it will mesh. Now you can mesh. So give it 32,000 generate. So you can reduce up to 5,000 or 5,000 or something, 3,000, something like this. So it will take less time, and but for the proper result or something like this, we need to make it proper mesh. It doesn't matter. We want to do default. Yeah, right now make it default. We'll change it later. So for the bottom die, again we have to mesh. So we will mesh bottom die also. After meshing, we will change the position of objects, and yeah, then we will do other steps. Yes. Now let's change the position, object positions. So right now, first you should drag. For example, here is the bottom die, and I want to drag it at minus z because minus z goes down. So I will click here and just make it down. So you can see it's going down, and top die should be in the positive direction upwards. So it will go up, but you see there is space or something. So you need to make it connected with each other. So for that you need interference. Go to interference. Here top die should go downward. Minus mean down. Top die should go down, and its reference is workpiece. So yeah, we will apply top die to workpiece. So you see it's interferenced, and bottom die, its reference is workpiece, and it will also go in upper direction to make proper contact with the, maybe it's a little bit down or maybe little bit up, but when we use interference, so it will just connect the top of the object. We are done here. So after that, what we have to do, we have to movement. So this the real game, or yeah, here comes the problem why we are not getting the exact results. So as per question, we have, yeah, there are some calculations. Okay, so I have done these calculations, so I will show you how you can do, or what should be done. So for example, here you don't use constant, here you will use function of stroke. Okay, and you have to define the function. If you want to write the function, you will write like 0 and 1, 2, 3, 4, 5. So it's a stroke. We have given how much top die will do the stroke of 5 millimeter. So it will start from 0, 1, 2, 3, 4, and simultaneously there is speed. We have to change the speed. Since the speed is not given, but we have to calculate it. I will later show you how to calculate and everything. So for our question, for 0 it should be 70 speed, 65 at 1, 60 at 2, 3, 55, 50 and 45. So yeah, you want to save it, save it. If you want to save it in your PC or something like this, so it will be saved. For example, if you want to use it in the future or yeah, for the next problem or something like this, so it's done. So we should apply. When you will apply, you will see the linear line. So as the stroke is increasing, the speed of die will reduce. So it will give us a proper result that we need. Strength rate. So okay, here then we need the boundary conditions. Okay, so we will go to the boundary conditions. So this is the top die. So for top die, I already had defined the whole object for the default. When it was asking, when I messed it, it was asking about default. When the default, it default the whole object. So you need to just cancel it here, rotate it, go to this, and you need just the bottom of top die because it's touching with the workpiece. So we need just this one. So for this, we click here, we click here, it's selected. Then we go here, add boundary conditions. Now we go to the bottom die. So the workpiece is attached to the bottom die is attached to the workpiece, but the only top surface of the bottom die is attached. So we will click here. Oh, it's symmetry plane. So no, you have to go here, heat, and it's already defined. You have to cancel it. You go here, you select this top surface, and you select. It's done. So yeah, workpiece. If you remember, the workpiece has a temperature, environment temperature. So you have to assign environment temperature. It was 250. You can see in the question the environment temperature, something like this. Okay, so we are done with the boundary conditions. Now we will do the enter object. In the enter object, what we need to do, we need to edit here, and we need to go here, and you have to select hot forging lubricated, and for thermal you need to go here, select forming, and then you need to close it, and you have to apply to other relations. So yeah, it's applied to other relation which was downwards of. So then you need to, for this, you need to, yeah, tolerance. You need to see the tolerance, how much tolerance it is with the top die with workpiece. So yeah, the tolerance is it's 0.25, something like this. So we will generate. You see the tolerance is generated. Now we need to, okay, now last steps come the simulation. So again here we have to take care that there should be heat transfer and number of simulation steps. I will choose 177. Reason I will tell you why. Maybe if I get proper result, then I will tell you. And for the time, we have to assign time. How much I calculated? Tell me how much I calculated. I calculated 0.00588. Yeah. I need to be sure, because if I put a wrong, then it will Yeah, 0 0.0 0.00588. Let's stop. So if you want, you remember our die will go and stop in the 5 millimeter or yeah. So primary die displacement in the z direction, it's actually in minus z. So no need to do something here special. So we will just mhm. uh, don't just focus here so much. 5 millimeter, just do it. So we will now see if we have done proper, so we can generate the data. Let's generate it. It's generated, so we will close, we will save here, and we will close. Now the simulation time will take yeah, it will take some time, so I will run it. Since we have 177 steps, so it will take time, so I will pause the video. When any message come, then I will pause video, then I will reopen or resume it. So this is the pause recording. Yeah, so it's about to complete. I had 177 steps, so it's 174. So if we get results, nearby results, then we will be done. If the results are not correct, you know the steps how to do it, or you can manage the other process. So 177, now it will stop. Yeah, normal stop. Now we go to the deform post. Here there are few few steps, then you will get the graph. And if the results are, yeah, so first we will slice it, yeah. So from here we go here, it gets sliced, we click OK, and then try to make it like this, and this is pointer, just make it in the middle. Why in middle? I will tell you later. So make it next, finish. We are done with these two steps. So now we will make the graph. So we go to the strain rate. This is the strain rate, right? And we need effective strain rate. So if you need in shaded, it will be in shaded, but global is from 0 to 25 maximum. I don't know what we need, just apply it. So yeah, if we see, it's from 0 to 24. Let's make it up to the 7. So user, and make it 7, and when we apply, it becomes from 0 to 7. So we will close it. Yeah, it's loading. Now we will run it. Let's see what happens. I hope. Cross your fingers. So play forward. Yeah, it's going from 6. It's, yeah, 6 to 5. Yeah, so in the end it becomes 5. So yeah, this is all. So if you want proper constant horizontal, or maybe not 6 but maybe 5 point something or something, then you need to change the values. So for that you need to change, for example, what you need to change, you need to change the time in the simulation. Okay, and I put 0.00588. So maybe there is some mistake in calculation, or maybe when I put the table in the moment and that table was not correct. So you know how to do things. And in the simulation there is also a stop criteria. If you want to stop the process maybe at the 5 mm, because our object stops at 5, so you can do like this. So yeah, window is open for you, and let's finish it, and maybe you can guys do better.